Okay, so we're going to be talking about scatterplots, which is the basic intro to linear relations or anything to do with lines, mainly because you guys have to know how to, plot a point. Okay, so when you plot a point, okay, we have a collection of coordinates which are in the form of x and y. Okay, so what you do first is find whatever your x value is first. So for example, someone give me a number for x here. 7. Okay, what's the value for y? 5. Okay, so what you're going to do first is you're going to identify your x value on the x-axis. So you're going to identify where 7 is. So 1, 2, 3, 4, 5, 6, 7. 7 is right here. And now you're going to identify where 5 is on your y-axis. So you're basically going to go up and find 5, which is around here. So this would be your point. That would be 7, 5. If I plot a point right here, what would it be? This one. X first and y after. X first, y after. Kareem.
3 and 2.
Yep, 3 and 2. 3 and 2. 3 and 2. Okay. How about this one over here?
2, 9.
1, 4. Okay, and then the next one, which is right here, what would that be? David, 2 and 3. So remember, it's x first, then y comes after. So don't get it mixed up. Remember, x is horizontal, y is vertical. Or that y to the sky. I don't even know what the x is. You know, that saying they said in grade 8. I don't remember either. Something with the x and y to the sky. I don't know what it is.
Excellent.
Y to the sky, because it's pointing up. That's what it says. I don't know. That's what I learned when I was in elementary school.
I didn't have no different, I guess.
So basically, a scatter plot graph is just a bunch of dots. Okay? That's it. We're good.
That was it.
I'm joking. No, there's more. So, however, when you have a scatter plot, you can either have a positive relationship or correlation. You can have something called a negative relationship or correlation, a constant relationship and correlation, or no correlation at all. Okay? But there's a couple terms I want you guys to, let's see if you guys can refresh your memory on this. So you have something called the line of best fit. We have something called interpolation. And we have something called extrapolation.
They also went with fancy words.
They are fancy words.
For saying basics.
Do you guys remember what a line of best fit is?
The line that goes
Can you come up with a definition based off the word or
yeah,
phrase?
easy.
Not the line of best fit.
It's line.
Nope.
It's the line that doesn't fit best.
It does fit best though. Yes, Sean?
Is it a line where like the numbers are like completely apart?
If you picked a different word other than numbers, I may say you're right. Kareem.
The line that fits like that fits exactly on the line of the graph.
Yeah.
Almond?
Pardon?
Shh.
Does the line like start at the first dot and then the last dot, and it's just like
It's a diagonal line, but you guys are kind of right. It's a diagonal line that is very close to all of the points on the scatter plot. It may not hit all of them, but it's relatively close to all of them when you draw it. So I'm going to show you what it looks like.
So interpolation is not.
We're not talking about interpolation. We're talking about line of best fit right now.
And interpolation after that.
Yeah. So we have, say, my scatter plot like this. So my line of best fit would have to go closer to either set of dots. So you'd have to try to fit it where each dot is like equidistant from the line or as equal from distant as the line of best fit is. So if I were to draw a line, this would be my line of best fit. Obviously, some of you may draw it a bit different, but I were to draw it like this. As you can see, the dots are close enough to the line of best fit, okay?
The example number 5 is the line, is the line of best fit.
So let me give my definition, and then I'll go. So line of best fit is just a line that goes through some of the points on the scatter plot. So as you can see here, the only point it went through was one of them, but everything else was pretty much of equal distance from that line of best fit. So is this line going up or down, this line of best fit? Up. So is it positive or negative correlation? It's positive correlation because there's a positive relationship between the points. They're all going up. So what would interpolation mean? I know you guys haven't heard this or may have. What do you think? Well, I'll tell you right now, both of these have to do with predicting points on the graph. What do you think interpolation means? Are we using the data within the graph, or do we have to extend outside of the scatter plot? Adam? Yeah. So interpolation is you're making predictions within the scatter plot using your line of best fit.
This is required.
Using line of best fits. And data within the scatter plot.
Windows XP memorizing.
Yes, Gian.
Wait, so like interpret. Okay, so I'm not really brushed up on statistics here, but like kind of similar to interpretation, right?
Yep. So you're
Okay.
basically trying to make a prediction based off the data you have and using that line of best fit. So for example, let's say, let me use my purple. So everything's going up by 1, okay? So let's say I want to find the y value in this scatter plot where x is 3. So I know x is 3 is over here, right? Because it's the third tick from the origin. So what I'm going to do is I'm going to go up until it hits my red line, okay? I'm going to make a point over here. And in order to determine the y value of that point within the scatter plot, I have to draw a horizontal line from that point until it hits the y-axis. So roughly, what is my predicted point within this graph? Adam? Roughly 3 and 3. If I really wanted to go to x is equal to 5, I can do the same thing. 1, 2, 3, 4, 5 is over here. I go up until my line hits the line of best fits. And then I have to go across.
And do you have to use like a different color or something like that when you're actually?
Well, it's easier for, well, not really, but if you like to be organized in the colorful sense, feel free.
Even arrows.
Wait, is this like a process? Like,
I'm just showing it for the sake of making it organized as possible for you guys to understand.
but you don't have to like do that when you're plotting, right?
No. So what would my predicted point be when x is 5? What is my y value? Around 4.5. Well, again, remember, my line of best fit, your line of best fit, and everyone else's line of best fit might be different. So it might be off by a bit. But interpolation means you're using the data in the scatter plot and predicting a certain point using your line of best fit. Now, what do you think extrapolation means?
Same thing, but you know out the graph.
Yep. Making predictions outside of the data you have using your line of best fit. Do I have room to show an example here? Let me see. We'll do it over here. So this is going to be an example of extrapolation. Okay. So I'm going to have my set of axes, my y and my x, and I'm going to have some random points. So here, 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 here. So I'm going to draw my line of best fit. Remember, it has to be as close as possible to all the points. So if I want to use extrapolation, what would I do? Yeah. So basically, let's just say I have 1, 2, 3, 4, 5. The last point on my scatter plot happens at around 5 and a specific y value. Okay. So if you want to figure out your y values after that point, this would be called extrapolation because you're extending beyond the data you already have. So let me do this. So this is my line of best fit again. Let me draw it again. So if I want to find out a point that's outside of the last point, for example, here is 6, I'm going to take my line at 6. I'm going to draw a vertical line until it hits my line of best fit, which is here. And I'm going to draw a horizontal line to where it hits the y-axis. So let me just go up by ones. So roughly, what is my point that is outside of that graph? So this is 7, that's 8. So I know my x value is 6. What's my y value? What's between 7 and 8? 7.5. So that would be my extrapolated point because I extended my line of best fit outside of the data that I had. We're good? Any clarifications? So now we're going to be talking about positive correlation. So just copy this down. I didn't give you the note today because it was too many pages. So a positive correlation is if the x coordinates and the y coordinates both increase, then the correlation is positive. So as you can see here, all these scattered points have a positive trend, okay? Because if I draw my line of best fit, it's going which way, up or down? Up. So if my line of best fit is going up, it means my data has a positive correlation. So copy that definition down. So next we have something called, well, positive correlation. An example of that would be as you get older, you're supposed to get taller. Okay? That would be a positive correlation. I mean, it would be very weird if you did the opposite, if you shrunk as you get older, but I think that happens once you get older and your back starts giving up on you and you start kind of hunching over, then you get smaller.
Yeah.
Okay, now we have something called a negative correlation. So if this definition is too wordy, a negative correlation happens is when you see a negative trend happening in the scatter plot. So if I draw my line of best fit and it's going down, what type of correlation do I have? Negative. So a simple definition would be when your line of best fit is decreasing, you have a negative correlation in the scatter plot. And that way you avoid this wordy definition. So now we have something that's no correlation, or in other words, simple definition. You have random points on the scatter plot and they make no sense. So no correlation means the scatter plot has random points everywhere and they make no sense, which means they don't make a positive line of best fit or a negative line of best fit. Okay, so like I said, no correlation means there's no pattern, everything's random, so there's no correlation within this scatter plot. Example of something with no correlation is your like shoe size in the basketball shoe and your shooting percentage. Your shoe size should not have an effect on how you shoot the ball. That doesn't. got a couple more things to say. So there's also something called constant correlation, which means that the scatter plots are always around the same y value. Okay, so as you can see here, let's say my y value is 6. All of my scatter plots are around a y value of 6, which means that there is some consistency between them. Okay, so a constant correlation is when your y values on the scatter plot are roughly the same. So that's it for today. So do that worksheet I gave you, and then tomorrow we'll do a new lesson. Actually, no, tomorrow's going to be a chill day. I don't want to do much tomorrow.